All right, so what identity do we have here, class? Yeah, you should recognize that you have a negative angle. They call that the negative angle identity. On your formula sheet, what does it tell you about if a cosine of a negative angle is equal to? Just cosine of theta. So if we have cosine of negative 75 degrees, then we just need to find cosine of 75 degrees. What does that mean for us? Well, if I look at my unit circle, is 75 on my unit circle? No. Now I could type cosine of 75 into my calculator and get decimals, but if I'm asked to find the exact value, exact means what? Radicals or fractions. Okay? And I don't have cosine of 75, then I can either find the sum or difference of cosine. What does that mean? I can add two angles together. We did this in the warm-up. We can add what two numbers?
45.
30 plus 45. Now, a couple of students are asking me at this time, does it matter the order in which you write them? The answer is no. Although your work might look a little bit different, your answer will be the same. Okay? Now I just need to identify my A and my B values. This is the A, and this is the B. And I'm basically going to use the sum identity of cosine. Cos, sine, ob, change the sign. So A is going to be 30 degrees. B is going to be a 45 degrees. So now I have cosine of 30 degrees times cosine of 45 degrees minus sine of 30 degrees times sine of 45 degrees. Now if you look on your unit circle, cosine of 30 is radical 3 over 2. Cosine of 45, radical 2 over 2. I have this minus sign. Sine at 30, 1/2. And sine at 45. Remember, it's multiplication here because there's no math operation. So basically what I'm going to do now is just multiply across. Because they're both radicals, then I have radical 6 over 4 minus radical 2 over 4. These are not like terms, so I cannot combine them. So it's radical 6 minus radical 2 all over 4. And this would be my answer. Now, what would happen if you didn't see the negative angle identity? Then you can still use the, you would just have negative angles to work with. What does that mean? Cosine of, you can use the same two numbers, negative 30 degrees plus a negative 45 degrees. Now do note, I wrote a plus sign here, and I would not make this a minus 45 degrees. I guess you could. But essentially you're doing the same problem, but the only difference is now you're going negative angles. What does that mean? Instead of working in quadrant 1, which I would recommend in today and tomorrow's lesson, you're probably going to have to work where now? Where do negative angles go? This direction, right? Does that make sense? And then if you did that, you can add a coterminal angle and get something like this. And you'll notice why you kind of don't want to do this. If you add 360 degrees, I get 330 plus 315. Are those numbers kind of big? Yeah. But they work out to be the same thing, and you'll notice that if you evaluate this, you'll still get the same answer. So in some ways, if you know your identities, it makes the numbers a lot smaller, and we could just focus on quadrant. Big idea? This is not on the unit circle. Now we're using the sum identity of cosine. If you had to break this up into steps, this is something you need to do. Class, what's the first thing we did over here? Negative angle identity. So look at your identities. Which identity did we use, class? Sum or difference? This is called the sum identity of cosine. Write down your formula or your identity. Substitute your A and B values. And then over here we just simplified.